Screen. My name is Brandon Bogard, and this is my portfolio review. First, a little bit about myself. I was born in Birmingham, Alabama, and I've lived in Alabama all of my life. I went to Vestavia Hills High School, which is a public high school. The minute I stepped foot in Barry, I knew this was exactly where I wanted to go. I came in undecided, but then second semester of my freshman year, I took CRT 101, the Intro to Creative Tech course. I loved it. So I immediately changed my major to creative technologies and did a minor in computer science and business as well. Over the past few years, in taking the multitude of different classes between creative tech, computer science, and business, I learned that coding is something that I really enjoy. It fits my mindset where usually it either works or doesn't, and there's a set reason, at least in the ones I have done, and that it just makes sense to me. And that ties directly into my theme, which is code-based automation for everyday applications. When looking over my projects, I've noticed a lot of them have been where I've taken a device that is used every day, such as a car or spatula, to give two examples, and automate it through some type of code. One of the first projects that used this is the Hackberry Autocart. This is a self-driving go-kart that we worked on for our vehicles class. It uses 3 different methods: self-drive, LiDAR, GPS, and a camera. LiDAR is one of the ones my group worked with. And what the LiDAR does is the device spins around really fast, sending out lasers, and it times the amount of time it takes the laser to reflect. In doing so, it can collect data about the distance between itself and other objects, and thereby make a map of where objects are in relation to the cart. However, the distances were not exactly, they weren't using traditional measurement. They were longer than a foot, but shorter than a meter. We dubbed them LiDAR units, and one of the challenges for this was actually figuring out how many LiDAR units we needed. As you can see here in the moving GIF, my group is testing the stop function of the LiDAR. There is no hand on the gas or the brake, and no one is touching the wheel at all. The cart is stopping by itself. The way it does is we are taking the data that is collected by LiDAR, and it puts it into a 400 by 400 pixel grid, and we're taking that grid, basically cutting out a rectangle in front of the cart and using that data to see what objects are in front. We ignored the data behind the cart because since we were going forward, there's no need to worry about any of that stuff. My group also worked with the GPS portion. As you can see in this GIF, the cart is trying to navigate from one end of the parking lot to the other. The way the GPS does this is that it takes in the start GPS location, the end GPS location, and the cart's current and past locations, and makes 2 different paths. One of the paths is where the cart wants to go, and one of the paths is where the cart is currently going. And we used micro adjustments to try and keep those paths as similar as possible. Also on screen here is the state diagram that we used for the GPS when coding it. Before we do anything, we had to make sure that the cart knew where it was and knew where it was going, or else it'd be pointless to start it, because then once everything is set, the cart starts, and we constantly check every time the program goes through one rotation, essentially, well, like it runs through the program, it's checking and updating the paths and the deviation from the paths. When the deviation gets more than a certain number of degrees, I think it was like 1% off or less than 1, it was around there. What we did was we had it micro adjust, which is where it doesn't do a full turn, but does a quick turn to try and stay on the path. And that brings me to another challenge of this cart, which is actually turning. Turning with a car is something we do every day. However, doing it automatically has many more steps than one might think. For example, to turn left, first, you have to make a turn, instead of just turning and adjusting on the fly. The way we did this is it turned a certain number of rotations. There were magnets on the wheel, so we could know exactly, we could basically have counters for turn rotations. Then it had to stop. And once it stopped, it couldn't go back immediately. We had to make it wait for a certain amount of time. We had to find that time because if it waited too long, it'd be too far left. Then we had to make it turn back the same amount of time, or else it would start going right, and we would have to adjust from there, then stop. As you can see, it's a lot harder to do a single turn automatically than it is manually. Overall, I think that this project demonstrates my theme because a go-kart is something that people use every day, and using code, I have started to automate it. Now, this project is not finished. If not for the quarantine and all the closings, I would have loved to work on it more. I know that the final iteration of this is where it goes back and forth from Hackberry Lab to the Visitor Center, picking up the potential students to to show them what Hackberry is like. For the next project that I believe works with my theme, it was a summer project I did with UAB. I work with the head of the computer science graduate program and a dental graduate student. The goal of this project was to take in a dental transcript and have it basically pull all the data out where it's in a format where it can automatically be put into a program. Traditionally, this task is something that is done by nurses where they record what the dentist says and then put it into the program later. Our goal for this project was to automate that process in order to allow the nurses to be free up their time in order to do other things. Now, just like the autocart, this is still an ongoing project. And I'm still working with the professor and the student. So about how this works is, as you can see here, over on the left, there is a transcript, and this is what the program is input into the program. The transcript is fairly dense. As you can see, there's a lot of information and a bunch of different dental terms. And if you see to the right, what the program does is it's pulled out all the information. It always checks for whether teeth are here or not, because that is one of the most useful things. Then it pulls out the other information in a sentence. However, some of the challenges concerning this project are grammar. Humans understand things that machines cannot. If you do not specifically tell the program that it does not do it. See, this is a good example right here. As you can see, these two sentences are very similar, have a bunch of similar terms, but one of them only talks about composites that are being planned, and the other one talks about how there's some existing composites and some others that need to be planned. One other big challenge that I'm currently working through is regarding comma-separated values. Because at certain points, there are lists of values where each of the things separated by a comma corresponds to a different list. For example, just a list of items that needs to be noted. Otherwise, comma-separated values are it's just a list of things that correspond to a single earlier item. So the program needs to be able to differentiate between putting all the information into one group versus separating it. That is what I am currently working on with this project. And it is, like I said earlier, it's still ongoing, and as I have free time, I am slowly making progress. As for my next project, it is an Autoflip spatula. The problem that I was trying to solve here is that there's certain groups of people who have trouble flipping using a spatula. The main one that was in my mind when I was making this device was people with Parkinson's. Their hands tend to shake, making it hard to use utensils such as a spatula. So I decided I wanted to make something that could fix that. As you can see here, it did work. This was a hackathon project, so it was made within 4 hours. And how it works is, as you can see, there's a servo motor attached to the handle, and when a button is pressed, the servo spins. It is a fairly simple design, but it works for its intended purpose. One of the challenges for this was the joint strength, because a normal spatula is an entirely connected piece. However, since the Autoflip spatula that I made the joint has to move, it was a big worry of mine that if too much stress is put on it, the joint would snap off. So the way I tried to solve this was with some adhesive. In the future, if I was to update this prototype, I would like to actually embed the servo into the handle rather than just connecting it with adhesive. That would allow for a lot stronger of a grip and less chance. Another update that I would like to do is to tidy up some of the wires. Like I said, there's a hackathon project, so I was more concerned with if it works rather than if it looks super nice. In the future, I would like to make it so that instead of having a lot of wires everywhere, it is just a solid piece that can easily be used by anyone. And the reason this connects to my theme is I did take an object that people use on a somewhat daily basis. I actually used a spatula earlier today and automated it in a way that makes it easier for people to use, specifically people who have a hard time using spatulas normally. The final project that I'm going to talk about is my capstone project. But this capstone project was about teaching nested if statements to 4th grade elementary students. The reason I chose this project was that, as I said earlier, I became really fascinated with coding, and I wish that I had the chance to do it earlier. My high school did not teach any coding, so I was first exposed to it really in college. And I would love for students to be able to experience this and get used to it and have opportunities that I did not. So this is an example of a nested if statement that I'm trying to get the students to understand. The way this one goes is if Tim is going to the grocery store and has not had lunch, he'll stay at the store an extra 30 minutes. If he has eaten, he will stop by the park for those 30 minutes instead. Then if he's not going to the store, he will stay at home. And then for the information normal shop takes an hour and a half. He has not eaten lunch and needs to pick up a few groceries. Then you have to figure out how long Tim will stay in the store. The answer to this is 2 hours, because he both has not eaten lunch and is going to the store, gives us the extra 30 minutes for the sandwich plus the hour and a half. The way I worked on this was, well, my original design was using this PCB. As you can see here, I was going to have essentially a binary tree of lights where the student go down and reach certain destinations. I will show those in just a moment. What I was playing is the questions that the students have to answer appear on the LCD screen, and they use 3 position switches to navigate down the lights. However, there was one of the challenges with this was the soldering of everything together. Soldering is not my strongest suit, and I had a bit of trouble, especially because I was trying to do it here at home without a lot of the resources that the lab had. So unfortunately, I could not get the LCD screen to work properly. So what I did instead was I used the strip of LEDs that I had here, and I labeled everything in order to make up for the fact that it was not in the same shape as the original design. As you can see here to the left, the code is still set up in this way where the student starts at the start state and has to go to a specific destination using the 3 position switches. Throughout when testing this device, I found that when asking a nested if statement to people before and after, it did improve their time afterwards by approximately half their time throughout the testing. However, I would very much like to, unfortunately, I could not test it with my original audience. I would very much like to do so in order to get more data. The people that I tested with were the people in my house, my parents and sister. They had no coding experience. However, their grasp of logic is more advanced than a fourth grader's would be. So to get better data, I would very much like to test it with the original audience. Overall, though, I feel that even though this device does not look the way I envisioned it, it does accomplish the task I set out. And finally, I have my future plans. I am going to go to the University of Birmingham in Alabama starting in the fall. I am going to go there for a master's in computer science. The reason I'm doing this is while I love creative technologies, it is still a fairly new field. And considering how much I enjoy coding, a master's in coding will advance my future prospects. I'm going to go into the general studies for computer science, though I am currently looking at cybersecurity as an option. One of the at UAB, they have a place called the Facebook Suite, which works closely with Facebook in order to stop like hackers and hate speech and other cybersecurity measures. So I feel like doing that would be a good experience. And last thing, I mentioned earlier that I was working with the graduate professor, the head of the computer science graduate program on the project. So I've already made a good connection with her.